Welcome! In this demo, you will discover how BILCO, CASPEO's data reconciliation by mass balancing software, simplifies one of the biggest challenges in mineral processing and extractive metallurgy, transforming inconsistent process data into reliable, coherent information. We will walk through an example applied to a copper concentrator plant to show how easily BILCO delivers fast and accurate results. In mineral processing, measurements are never perfect. Sensors drift, samples vary, and errors accumulate. Data reconciliation is the methodology that takes all those inconsistent measurements and computes the most probable, coherent estimated values, ensuring that mass and metal balances close. Let's illustrate this process with a simple copper concentrator flow sheet. Our goal is to determine the actual copper recovery rate of this plant. Our plant has one feed and two outputs, the copper concentrate and the tailings. These are measured solid mass flow rate and copper grades. We immediately notice that 500 tons feed the concentrator, while only 475 tons report to the outputs. But these numbers don't quite add up. An imbalance appears between input and outputs. The input does not match the sum of the outputs. Even more concerning, we find 190 kilograms more copper in the outputs than in the feed, an impossible situation that breaks material conservation law. What goes in, goes out. Due to sampling and measurement errors, the measured data are inconsistent and redundant. If we only had feed and concentrate measurements, we wouldn't detect the imbalance, but since the full set exists, we must deal with it. Let's continue with our objective: determine the actual copper recovery rate of the concentrator. One method is to disregard the measurement on one of the streams and to do the calculation based on the two other streams. Using these reconstructed values, we can then compute recovery as copper in concentrate divided by copper in the feed. If feed is calculated from concentrate and tailings, recovery is 81.3%. If we use measured feed and concentrate, recovery rises to 83.3%. If the concentrate is calculated from feed and tailings, we obtain 80.8%. We now have three possible recoveries and no basis for choosing the correct one. A production manager may be tempted to select the highest value, but this mass balance approach is not reliable nor consistent over time. Then it relies only on partial data. Introducing measurement errors helps us understand the situation. Each measurement is characterized by an error expressed as a relative error in percent, depending on the sensor accuracy, the methods used, the sampling error. For the mass flow rate, the measurement error is 10% for the feed and the concentrate and 25% for the tailings. For the copper content, the measurement error is 10% for the tailings, 5% for the feed, and 1% for the concentrate. We observe that copper grades are significantly more accurate than masses, a situation frequently encountered in real plants. This is because dry masses rely on moisture determination, which has high sampling variability driven by weather conditions, making moisture accuracy poor. Given that copper contents are more accurate, let's keep all three grades and compute the mass flow rates. Of course, we need to retain one mass flow rate measurement. If we keep the feed mass flow rate and calculate the other two flow rates, we obtain a recovery of 79.69%. Keeping the concentrate mass flow rate generates yet another value. Tailings mass is too uncertain to keep. At this point, we have 5 possible recovery values. All these methods use only partial data and cannot provide a reliable answer, a situation that creates confusion and undermines decision-making. This is where data reconciliation and BILCO come in. Instead of considering only a part of available experimental data, BILCO performs full data reconciliation. It uses all measured data simultaneously and adjusts values according to their measurement errors while enforcing material conservation laws. The estimated values are not the actual measurements, but the most consistent ones based on all available information. The confidence in these estimates is enhanced by the redundancy of the data and the high accuracy of the copper content in the concentrate. The result? A single coherent mass balance with improved confidence levels. For our copper concentrator, here are reconciled values. They now obey material conservation and yield one clear and single recovery, 79.9%. After data reconciliation, we can observe that accurate measurements barely change while uncertain ones are adjusted appropriately. For example, tailings mass flow rate increases by 30 tons, a 6.9% shift, still well within its original 25% uncertainty. Most importantly, the final errors on the reconciled values are significantly reduced, improving confidence in every number used for plant performance tracking and decision-making. Let's see how easy it is to set up a reconciliation in BILCO. Start by drawing your flowsheet. Once a new file is created, select Graph Drawing in BILCO. A toolbox appears, allowing selection of icons. Select an icon and paste it into your file. Then select the Stream button and draw your streams with the mouse. You can assign a name for each stream and each node. The next step is to specify the phase model and define stream properties. In this example, we are tracking only the solid mass flow rate and the copper content. Units are tons per hour for the mass flow rate. Add the different chemical elements or minerals that you want to include. In this example, we are only interested in the percent of copper. You can now enter your measured data and the level of accuracy of each measurement. BILCO automatically analyzes the quality of the measured data, flags abnormal values, and allows you to edit constraints. In this window, you can adjust the constraints laws, for example, when you have phase transfer of chemical elements between solid and liquid during leaching. Even if you have very complex flowsheet, the material balance calculation in BILCO lasts less than 5 seconds. BILCO data reconciliation software makes your results easy to interpret. The comparison view shows measured versus estimated values, with a color-coded confidence indicator that helps the user to identify the quality of the data reconciliation. The measured data is represented as a point and its error range. If the estimated value is blue, it means that the level of confidence of the estimated value is inside the level of confidence of the measured value. If the estimated value is black, a part of the level of confidence is partly outside the measured data. A red color indicates that the level of confidence of the measured data may have been underestimated. All the data in BILCO can be exported directly to Excel for further analysis. With BILCO, data reconciliation becomes fast, reliable, and insightful. It improves your understanding of plant operations, ensures mass and metal balance consistency, and enhances decision-making confidence. By correcting measurements relative to their errors and enforcing material conservation, BILCO propagates accuracy throughout your circuit. Even complex processing plants are reconciled in seconds, saving engineers hours of manual work and uncertainty. BILCO, turning inconsistent measurements into trusted process data. For more information or a demo, visit caspeo.net or contact our experts.